Hello people, I'm Bharat Acharya. Welcome to a new video. So in today's video, we're going to learn these two instructions of 8085 called sim and rim. This is a continuation of the interrupts video. So the previous video we made was interrupt structure, where we learned the whole interrupt topic of 8085. So you saw all its interrupts, they are working, what happens when an interrupt occurs, how does the processor go to an ISR, etc. Now that's done. Now during that, the diagram that we had seen called the interrupt structure, that diagram has a lot to do with these two instructions, sim and rim. Now sim stands for set interrupt mask. I repeat, set interrupt mask. So this is an instruction by which we, the programmer, can mask interrupts and then again unmask them and then mask them again as many times as we like. What do you mean by masking? Disabling. Now you would say we can also disable interrupts by writing the instruction DI. Agreed. But when you write DI, all interrupts are disabled. Whereas in sim, you can choose and pick which one you want, which one you don't want. So that's what basically sim instruction does. Now that's not the only thing though. Sim is a multi-purpose instruction. The part that I explained to you right now happens over here, where we choose the masking and masking. It's also used to reset RST 7.5. Again, this has deep connection with what we had seen in that diagram. If you remember, for RST 7.5, in the D flip-flop, at the clear part, there was an input using an OR gate called reset RST 7.5. That was because of the property RST 7.5 is edge triggered. If you remember, I have given a detailed explanation in that video. That was a very long video. So I've explained that part. So to enforce the edge triggered nature of RST 7.5, you have this bit. And then finally you have serial communication. Long time back, 8085 architecture, if you remember that, you remember on the top of the architecture, there were two pins on the top right for your side. There were two pins, SID and SOD, stands for serial input data and serial output data. So using that, you can do serial communication. What do you mean by serial communication? Data, transmitting data bit by bit, one bit at a time. So you can, when you transmit one bit at a time, what you need to decide is whether you want to send a 0 or a 1. So that is decided over here. Now that was the brief. Of course, I'm going to be showing you every bit what happens when it is 1 and 0 and why all these bits are necessary. Each bit over here is important. So I'll be showing you that. So there are three functions. Serial communication, I've used different colors so that it's easily distinguishable. I hope you can identify the colors. So anyway, this is for serial communication, this is for resetting 7.5, and this is for masking and unmasking interrupts. So that was sim. What happens in rim? Rim stands for read interrupt mask. In sim, you mask the interrupts. In rim, you can read back what information you had given. You can find out about the interrupt structure. This is nothing else but the whole diagram of interrupt structure read into a single command, into a single register. This information tells you which interrupts are masked. Okay? This is where you are masking. This is where you're finding out who is masked, who is unmasked. It will tell you whether interrupts are enabled or not. It will tell you which interrupts are pending. If you remember, I had explained to you what is a pending interrupt. And finally, it will tell you what is there on the SID pin. On the SOD pin, you send data. On the SID pin, you read data. So whether you are reading a 0 or a 1, as in whether the pin contains a 0 or a 1, that information is obtained over here. So sim is a command that we give to enforce action. Rim is a command that we give to read what is going on in the system. So I'm going to be explaining both of them to you along with instructions how to use sim and rim. Now, the first thing which you do in sim, as the name says, set interrupt mask. So let's focus on the most important characteristic first. These three bits are used to mask the interrupts. Now, if you remember the interrupt structure of 8085, which are the three interrupts that can be affected by sim instruction? 7.5, 6.5 and 5.5. Trap can never be masked. INTR cannot be individually masked by sim. It can only be disabled by DI. I hope you remember that. So these are the three interrupts. It's very obvious. Whichever bit you keep as 1, you're masking that interrupt as easy as possible. So suppose I've kept 0, 0, 1. What does that mean? I have masked 5.5. Suppose I keep 1, 0, 1 as an example. I have masked 7.5. Now I can unmask both of them and mask 6.5. Then mask all of them again. Then unmask as many times as you want. Now we will come to this bit in a minute. Okay, hold on. Reset RST 7.5. What did I say? RST 7.5 is what triggered? Edge triggered. Edge triggered means I want to see the signal going from 0 to 1. If it's already 1, I'm not impressed. So suppose I have already masked 7.5. For this duration, I have masked 7.5. 7.5 interrupt has occurred. If the interrupt has occurred, if you remember the flip-flop, which indicates that the interrupt has occurred but not yet been serviced, those D flip-flops, which also indicate the pending status of the interrupt. I hope you remember that. So what will happen when the interrupt occurs? The D flip-flop will become 1. When does the flip-flop become 0? When you go to the ISR. Since I have masked the interrupt, we are never going to go to the ISR. That means the flip-flop will remain 1. The interrupt has gone already, but the flip-flop is still 1. Now, I decide to unmask 7.5. I have finished the region when I didn't want it. Now I want 7.5, so I unmask. When I unmask 7.5, what is my intention? I want to service the interrupt that occurred during the mask time, during the unwanted time, or do I want to service new interrupts? I want to service new interrupts. But to service new interrupts, I have to first clear out the previously existing interrupt on 7.5. Because 7.5 is edge triggered, means if it's already high, it should not be allowed. It should be allowed if it goes from 0 to 1. So if it's already 1, I have to first clear out that interrupt. For that, there is an option called reset RST 7.5. It's only for 7.5 because 7.5 is the only one which is edge triggered. So by making this bit 1, you're going to reset that flip-flop. That flip-flop will become 0. If you remember, this condition was going on an OR gate into the clear of that flip-flop. So even if there was an older interrupt which had come and gone, the pin had become 0, but the flip-flop is still 1. This condition will clear off that flip-flop. Now if RST 7.5 is serviced, that means it was a new interrupt that has occurred, not the previous interrupt which had occurred at a time when you didn't want it. I had given the example also. Suppose you locked your keypad. Now you press a few keys. When you unlock the keypad, those keys that you had pressed should not be displayed because they had been pressed at a time when you're not interested in that interrupt. So to clear out the older interrupts, you need this feature. Being 7.5, you need this feature because it is edge triggered. So that's why you have this feature for RST 7.5. So if you keep this bit 1, you have cleared that flip-flop. If you keep this bit 0, you're doing nothing. So it's as good as not doing anything at all. It will not affect that flip-flop. This bit being 0 will not set the flip-flop. The flip-flop will be set when the interrupt occurs. So keeping it 0 will do nothing. Keeping it 1 will clear the flip-flop. This bit is don't care. Again, I'll come to this bit in a minute. First, understand this bit. SOD. SOD stands for serial output data. On 8085, there is a pin SOD. You want to send out data serially. Serially means 1 bit at a time. So you'll be sending 0, 1, 0, 1, whatever you want to send. So whether you want to send a 0 or a 1 is decided by this bit. If you keep this bit 0, you are sending a 0 on the SOD pin. If you keep this bit 1, you are sending a 1 on the SOD pin. This is also the principle behind the program to generate a continuous square wave using SOD pin. All you need to do is keep giving sim commands with a 0 and then a 1, then a 0 and a 1. Keep a delay between all of them. So your 0 will be prolonged, your 1 will be prolonged, then 0 will be prolonged, 1 will be prolonged, and this will end up producing a square wave. We'll be doing that program very soon, not in this video, but very soon. I've just given you the idea for it. Anyway. So, what does this bit decide? Whether you want to send a 0 or a 1. What does this bit decide? Whether you want to reset 7.5. What do these bits decide? Whether you want to mask 7.5, 6.5 and 5.5. This bit is don't care. Now, the bits which we have still not discussed is this one and this one. Now, why do we need these bits? Remember these words, what I'm saying. SIM is a multi-purpose instruction, meaning you can do several things using SIM. You can mask interrupts, you can reset 7.5, you can send serial data. There are 3 things you can do using SIM. The point is, you may not want to do all the 3 things every time. Did you understand what I'm saying? Suppose you only want to mask interrupts. That is your idea, your intention, just to mask interrupts. You are not interested in the SOD pin, you just want to mask interrupts. But to mask interrupts also you have to do SIM instruction. Now what will happen? Suppose you want to mask all the 3 as an example. You will keep these 3 bits as 1. You don't want to reset 7.5, okay, you will not bother about this, keep this bit as 0. This is don't care, fine. What happens over here? If you cannot keep this bit blank. Now if you keep a 0 will go out on SOD pin. If you keep a 1 will go out on SOD pin. Are you understanding this? The point is you don't want to disturb SOD pin. This bit decides whether you want to send a 0 or a 1. But before that you need another bit to decide whether you want to send serial data or not. Did you understand my point? Students say just send a 0 or send a 1. No, how can you do that? 0 is also a value, 1 is also a value. Suppose this SOD pin is connected to a tube light. and you don't know where the tube light is. You don't know whether it is on or off, and whether by sending 0 or 1 whether it will be turned on or off, because it may be an active high signal or an active low signal depending on how the tube light reads it. So you don't know what is the safe value over here. Students say it's a tube light, big deal, switch it on, what happens? No, if it is a tube light it's fine. If it is a missile, then what do you do? Basically the point is this SOD pin could be controlling any part of the circuit which you are totally uninterested in. You are not interested in sending serial data, you are interested only in masking. So there should be a bit that decides whether you want to do serial communication or not. This bit decides whether you want to send 0 or 1. This bit is called serial data enable. If you keep this bit 1, that means send data on SOD, then this bit will decide whether you are sending a 0 or 1. If you keep this bit 0, that means nothing. If this bit is 0, this bit becomes don't care. Whether you keep 0 or 1 is immaterial. Nothing will be sent out on SOD pin. Whatever was the earlier value will be retained. Please tell me, did you understand this? Similarly, suppose I am using SIM instruction to send serial data. Let's say I want to send a 1. Okay, send a 1 on the SOD pin. Since I want to send a 1, I will keep this bit 1. Since I want to send, I will keep this bit 1. You understood the difference, right? This says send and this says send a 1. Are you clear? This is don't care, you can keep anything you want, doesn't matter. I don't want to reset 7.5, fine, I will keep these 3 bits, this bit as 0. What about these 3 bits? Now, if you keep them 1, you are masking all the 3 interrupts. If you keep them 0, you are unmasking them. The point is, masking, unmasking is done by a fellow programmer who is not right now in communication with you. You have no interest in the masking section, your interest is to do serial communication. But still, you cannot keep these 3 bits blank. These tell whether you want to mask or unmask, but before that there should be a bit that says whether you want to do masking at all in the very first place. Student says, sir, what if I didn't want to do masking, why am I doing SIM? Because SIM is not only for masking, SIM is a multi-purpose instruction. It can be used for masking, it can be used for resetting 7.5, it can be used for sending serial data. Suppose your interest is right now only to send serial data. You don't want to reset 7.5, great, this is simple, just keep this bit 0, it does nothing. But if you keep these 3 bits 0, that doesn't mean it does nothing. That means it unmasks all the interrupts. What if you don't want to affect the masking pattern? Keep this bit as 0. This is called mask set enable. Only when this bit is 1, these 3 bits matter. Whatever pattern you give over here will be enforced as the masking pattern. If you keep this bit as 0, these 3 bits become don't care. Whatever you give over here will not affect the masking pattern. However the interrupts are masked or unmasked, that situation will remain the same. This instruction will not affect the masking pattern. Please tell me, did you understand? So there are 3 things you do using SIM. This part does masking. This bit, if it is 1, masking will happen. If it is 0, masking will not happen. This part sends serial data, but only if this bit is 1, serial data will be sent. If you say keep it 0, serial data will not be sent. And this is used to reset 7.5. If you keep it 1, you are resetting 7.5. If you keep it 0, no problem, you are doing nothing. So you don't need another protection for this. This 0 means do nothing. Please tell me, did you understand? In other words, you don't want to do masking, keep this bit 0. You don't want to do serial communication, keep this bit 0. You don't want to do resetting of 7.5, keep this bit as 0. So depending on what you want to do, based on that you make the bit 0 or 1. Please tell me, did you understand? That's it, that is your SIM instruction. Now, let's take a 1-minute revision. This bit tells whether you want to send 0 or 1. This bit tells whether you want to send or not. This bit is don't care. This bit decides whether you want to reset RST 7.5. This bit decides whether you want to do masking or not. And these 3 bits decide whether you want to mask the interrupts or unmask the interrupts. Please tell me, are you clear? Let's take a programming example. Suppose the question comes in the exam. Draw and explain SIM instruction. Hence, mask RST 5.5 and 6.5. That's it. That's your question. Mask RST 5.5 and 6.5. Come on. First you will explain the SIM instruction. Now, you want to do masking. So this bit will be 1. You have to, the question says you have to mask 6.5 and 5.5. So you'll keep these 2 bits 1. This bit is 0. They did not mention anything about resetting 7.5. Keep this as 0. This is don't care. Keep it as 0. They have not mentioned anything about serial communication. Keep this bit 0, that means you're not doing serial communication. Now whatever you keep over here is immaterial, whether you keep a 0 or 1, it's don't care. What is the number? 0. This number is B. You understand, right? You know how to read hexadecimal numbers. That is B. So total command value is 0BH. Now how do you give this? When you write SIM, first do MVI A, 0BH. So basically make your command, put it into A register, write SIM. MUP will copy this value from A register and do it according to the pattern of SIM. So basically you are the programmer, this is the MUPI, this is A register. A register is the channel between you and the MUPI. Put your number in A, write SIM, MUPI will take it from A and do the appropriate action. Please tell me, did you understand this? That was SIM. Now the next one, RIM. SIM stands for set interrupt mask. So by SIM you force a masking pattern. RIM, read interrupt mask. So by RIM you are finding out what is going on. You're not saying what to do, you're finding out what is going on. You are reading the masking pattern. Just like SIM, again A will be the channel between you and the MUPI. So when you do RIM, you just have to write RIM, nothing else. The moment you write RIM, MUPI will give you this information in A register. You look at A register, apply this combination on the pattern of A register, and you will understand what information is in which bit. Now this is the information you get. M7.5, 6.5, 5.5, very obvious. You had given a masking pattern, it will give you back. That's why the name read interrupt mask. So if these three bits are 0, 0, 1, what do you understand? RST 5.5 is masked. Okay, you are not masking, you are finding out which is masked. Are you clear? Now IE, remember in the interrupt structure diagram, right at the bottom there was interrupt enable flip-flop. If that flip-flop is 1, all interrupts are enabled. If that flip-flop is 0, all interrupts are disabled. Do you remember that? So this is the status of that flip-flop. All of this information comes from that diagram. In that diagram there was M7.5, 6.5, 5.5, that comes here. In that diagram there was IE flip-flop, that comes here. So if this bit is 1, that means interrupts are enabled. If this bit is 0, that means interrupts are disabled. Please tell me, did you understand? Next. I7.5, 6.5, 5.5. This tells you which interrupts are pending. What do you mean by pending interrupt? A pending interrupt is an interrupt that has occurred but not yet been serviced. When does an interrupt become pending? If two interrupts occur simultaneously, the higher priority interrupt gets serviced. The lower priority one remains pending. Are pending interrupts lost? No. Every interrupt has that flip-flop. Do you remember? 7.5, 6.5, 5.5, they all had it. Trap didn't have it because trap can never become pending. INTR didn't have it because INTR's pending status can be found out using 8259. The next chapter that you're going to learn, 8259 in that. So trap and INTR don't have that flip-flop. 7.5, 6.5, 5.5 had that. I'm talking about that D flip-flop which was there in the interrupt structure diagram. So it tells you which interrupt has occurred but not yet been serviced. In other words, it is pending. So suppose you get over here 100, you understand RST 7.5 is pending. It has occurred but not yet been serviced. And SID, in SIM you send serial data. In RIM you are reading serial data. Somebody is sending you serial data, it will come on the pin SID. Now being serial data, the bit data can only be a 0 or a 1. You want to know what it is, do a RIM, look at this bit. This bit will indicate. If it is 1, that means there is a 1 present on the SID pin. If it is 0, that means there is a 0 present on the SID pin. Please tell me, did you understand? So give me a recap of this. It's very simple. SIM was the big one. RIM is just too simple because in RIM you're not doing anything. Every time you do SIM, you cause a new action. You do RIM 1000 times, you're not causing any action. You're just finding out what is going on. This is the active instruction. This is the passive one. It just gives you back what information was given. So you can find out which interrupts are masked. You can find out whether interrupts are enabled. You can find out which interrupts have occurred but not yet been serviced, that is pending. And you can find out whether somebody has sent you a 0 or a 1 on the SID pin. How do you do RIM? Just RIM. In SIM, you form the number, put into A and write RIM, SIM. In RIM, you just write RIM, MUPI will form this pattern, put it into A. Now you look at A register, apply this pattern on it and you understand what's going on. As an example, suppose you get a question, this is common in Bombay University. Programmer has executed RIM and this is the pattern that he or she got. 1 0 0 1 0 0 0 0. What does that mean? First of all, what is this number? 9 0. What does this mean? Somebody has sent us 1 on the SID pin. INT RST 5.5 is pending, that means it has occurred but not yet been serviced. Interrupts are globally disabled and none of the interrupts are masked. Programmer has not used the masking option at all, so all interrupts right now are unmasked, but globally interrupts are disabled. That is it. So that was SIM and RIM instruction. I hope you enjoyed learning it. Wish you all the best. Do well.